Hey everyone, welcome to Bean to Bar Stool, a podcast that looks at the intersections of craft beer and craft chocolate. My name is David Nilsson. I'm an advanced Cicerone and the host of Bean to Bar Stool. Today we're continuing our series of short bonus episodes looking at how beer is made, focusing on basic ingredients and brewing processes. The two bonus episodes before this one looked at malt and hops and their associated processes. Today we are looking at yeast and fermentation. All of this has been taken from a full-length episode that came out last summer, episode 61, that walked all the way through the brewing process and all the major ingredients, so you can go back and listen to that in its entirety if you want to. Now, let's talk about yeast and fermentation. After the boil is complete, the beer will be separated from the coagulated proteins and the vegetal hop matter, collectively known as trub, and then chilled down and moved into fermenters. Then our third major beer ingredient takes over. The overwhelming majority of beer is fermented by one of two species of yeast from the same genus. Saccharomyces cerevisiae ferments ales and Saccharomyces pastorianus ferments lagers. We'll talk more about that distinction later on. Saccharomyces yeast is a microscopic fungus that consumes simple sugars and creates ethanol and carbon dioxide as byproducts. Once the brewer has cooled the unfermented beer down to the desired temperature for the yeast they're using, they add the yeast to the fermenter and let it do its thing. Fermentation will take anywhere from a few days to a couple weeks. During fermentation, the yeast will convert sugar into alcohol and CO2, but there are a host of other microbiological processes happening alongside this. The yeast is also absorbing oxygen early in the process, dividing into more yeast cells, absorbing nutrients such as nitrogen and zinc to keep itself healthy, consuming trace amounts of other compounds in the beer, and, depending on the strain of yeast being used, creating varying levels of many different aromatic compounds that will influence the taste of the finished beer. Depending on the desired result, the health of the yeast, and how well the process is planned and monitored, these flavors might be desirable or undesirable. When the yeast has finished fermenting the beer, it will usually settle to the bottom of the beer. In modern breweries, fermentation is done in vessels that have a cone-shaped bottom, allowing the brewer to harvest the yeast from a batch of beer and use it again if desired. There are a lot of flavor compounds yeast can potentially create in beer, some good and some bad. Esters will generally have fruity or floral aromas. If you've ever enjoyed a Hefeweizen, the banana flavor you get in that beer is from a yeast ester. Phenols generally have spicy, earthy, or even medicinal aromas. Going back to that Hefeweizen, the clove spice in that beer is from a yeast phenol. Some esters and phenols are pleasant, some are unpleasant, and some are pleasant on their own but shouldn't be present in certain styles. Some compounds the yeast can create are unpleasant or simply aren't desired in high concentrations or in certain styles. It's all about context. Earlier, I mentioned there are two main yeast species, one for ales and one for lagers, so let's spend a moment talking more about that. There are a lot of misconceptions about the difference between lager and ale. Thanks to mass-produced brands advertising bland, watery beers as the highest level of lager brewing, the average consumer thinks lager is code for flavorless or cheap. The truth is, lagers can be brewed with all the character and quality of ales, aren't necessarily weaker or milder beers than ales, and they certainly aren't easier to brew. Ale yeast, Saccharomyces cerevisiae, prefers to work at a higher brewing temperature than lager yeast, Saccharomyces pastorianus. The lower temperature for lager means the yeast produces fewer aroma and flavor compounds. From a sensory standpoint, this means there are generally fewer yeast-derived aromas and flavors in lagers than in ales. Lager yeast does its work without leaving much trace of itself behind. Within both species, there are many strains, and they perform slightly differently, allowing a brewer to select the strain that will work best for the beer they're brewing. Beyond that, lagers can be every bit as characterful as ales, so if you hear lager and think boring, think again. After fermentation is complete, the beer will undergo a resting period at low temperatures, a stage called conditioning or secondary fermentation, or depending on how long it's carried out, lagering. This rest allows flavors in the beer to come together, some solids to drop out, and rough edges to be sanded off. This lasts from days to months, and generally speaking, lagers condition longer than ales. The word lager actually means to store, referring to this extended cold temperature rest. The one major beer ingredient we haven't talked about actually makes up the majority of the volume of a beer, usually about 95%. Water is hugely important to brewing, but it's an ingredient we don't often talk about because it can be hard to understand its importance. Water isn't just water. Groundwater in different locations will vary in its concentration of different minerals, and these trace minerals will impact things like yeast health and how the flavors of malt and hops are perceived. Many historical styles developed in specific locations because of the chemistry of the water available. Today, brewers can adjust the water chemistry of their brewing water to suit the style of beer they want to brew. So, that was all a lot of information. Let's recap real quick. Beer is brewed from 4 main ingredients: water, malt, hops, and yeast. Malt is enzymatically active grain, usually barley, that gets mixed with hot water during the mash to convert starch into sugar and extract flavor, aroma, and mouthfeel components. The resulting wort is then boiled, and hops are added to extract bitterness and flavor and aroma. The liquid is then cooled down and yeast is added. The yeast ferments sugar into alcohol and carbon dioxide and can also contribute flavor and aroma. The beer rests for a bit, and then it's ready to be packaged or served. So that's a quick look at yeast and fermentation and their impact upon the flavor of beer. If you have any questions related to this, please reach out and ask those. I will do my best to answer them. I encourage you to go back and listen to the previous bonus clips on malt and hops or the full-length Beer Basics episode 61. You can listen to all of our episodes on beantobarstool.com or on your favorite podcast app or platform. Also want to remind everyone that issue 4 of Final Gravity, our print beer zine that celebrates personal, human-centered stories from the beer world, is available now on beantobarstool.com/shop, where you can also check out our entire catalog of zines. Thanks for listening to Bean to Barstool. I hope you enjoyed this bonus episode. Cheers.